All right, today we're going to pull back the curtain on one of the most important, but maybe least known protocols humming away inside your smartphone. It's called the Packet Data Convergence Protocol, or PDCP for short. Let's dive right in.
So, have you ever really stopped to think about this? You're like walking down the street, maybe on a video call, and your phone just seamlessly switches from one cell tower to the next. And you don't drop a single frame, right? It feels like actual magic. But it's not. It is an absolutely incredible feat of engineering.
And the hero of that entire magic trick? Well, it's PDCP. And this thing is not just a one-trick pony. Oh no, it's a security terminator, it's a mobility anchor, it's an efficiency engine, it's the gateway between the calm, stable internet and the wild, chaotic world of radio waves. It is the hidden manager in the background that makes everything just work.
Okay, so to really wrap our heads around what PDCP does, we first have to figure out where it lives. What's its specific job inside the incredibly complex communication stack of your phone.
And its position is what's so interesting. See, PDCP is kind of sandwiched right between the IP layer, that's where your apps and video streams live, and the radio layers down below, RLC and MAC, the guys that are actually getting the bits over the air. This makes PDCP, well, it makes it the ultimate middle manager. And just like any good manager, it knows exactly how to delegate. This is a brilliant division of labor, really. PDCP cares about the meaning of the data. It's asking the big questions. Is this secure? Is the user moving around? Do we need to compress this? Meanwhile, the layer below it, RLC, is just focused on one thing, reliability. Did the packet actually get there? And then you have MAC, the scheduler, whose only job is to decide when to send it. See? 3 totally distinct, super important jobs.
Okay, now if you only remember one thing from this section, make it this line right here. Seriously, this is pure gold. PDCP stabilizes IP, RLC stabilizes radio. That's it. PDCP's entire purpose is to shield the calm, predictable world of the internet from all the absolute chaos happening on the airwaves.
Now, it's important to know that PDCP doesn't treat all data the same way. Nope. It kind of wears 2 different hats. For the really critical network signals, that's what we call the control plane. It pulls out all the stops, ciphering and integrity protection. But for your actual data, your cat videos, the user plane, it only does ciphering and maybe some compression. And hey, here's a fantastic little interview trap for you. An LTE integrity protection is not applied to your user data. Why? It's just too computationally expensive.
All right, let's zoom in on that first big mission, security. This is where PDCP basically becomes a secret agent for your data, protecting all your information before it even touches the air.
So it's got 2 main tools in its spy kit. First up is ciphering. This basically scrambles your data, locking it in a digital safe with a secret key so nobody can eavesdrop. That's all about privacy. The second tool, integrity protection, is only for those important control plane messages. It adds a special digital signature, kind of like a wax seal, to make sure a command is really from the network and not from some hacker. That's all about authenticity.
So how does it make sure the encryption is always unique for every single packet? Well, the secret sauce is this thing called the count value. Just think of it like a totally unique serial number for every packet that goes out. It's made by combining a public part, the sequence number that just ticks up with every packet, and a secret part, the hyperframe number. Put them together, and you get this unique heartbeat for the security engine. It guarantees no 2 packets are ever encrypted the exact same way. And for any network engineers out there, this is a really crucial point. The security isn't based on some flimsy timer. It's based on this rock-solid packet counter. That's what makes the system so incredibly robust. A timer? That could drift. But the count? It makes sure the phone and the tower are always perfectly in sync, packet by packet, for both encryption and decryption.
Okay, let's move on to mission number 2, efficiency. You gotta remember, the airwaves are a finite resource, and it's PDCP's job to squeeze every last drop of performance out of them.
So here's the problem it's up against. Take something like a standard voice call over LTE. The actual voice data? Tiny, maybe 20 bytes. But the internet headers, the IP, UDP, and RTP stuff, that can be 60 bytes. Just think about that. You're spending 3 times more resources sending the envelope and the address label than you are sending the actual letter inside. It's a colossal waste.
The solution is a superpower, and it's called Robust Header Compression, or ROHC. And just look at the impact. It takes that massive 60-byte header and shrinks it all the way down to just 1 to 3 bytes. It does this by just stripping out all the repetitive information that doesn't need to be sent every single time. For real-time stuff like voice and video, this is an absolute game changer.
Yeah, just to put a fine point on it, we're talking about a reduction of over 90%. 90! Imagine if your data plan suddenly became 90% more efficient for things like voice calls. That's the incredible power of ROHC, and it's all managed by our hero, PDCP.
All right, now for what is, I would argue, PDCP's most complex and, honestly, its most magical function, managing mobility. This is all about making sure your connection survives as you move through the world. So when you move from one cell tower to another, PDCP transforms into what we call the mobility anchor. It's the one single stable point in the entire protocol stack that makes sure the handover is totally seamless to the apps running on your phone.
The whole process is like this beautifully choreographed four-step dance. Okay, step 1, the original tower freezes transmission and buffers your data. Step 2, it forwards all of that unsent data directly over to the new tower. Step 3, the new tower immediately starts transmitting to you. And finally, step 4, your phone sends a quick status report back, basically saying, hey, great job, but I'm just missing packet number 105. This ensures absolutely nothing gets lost in the shuffle.
And why does all this matter so much? Well, this is the entire reason your YouTube stream or your Zoom call survives a handover. By keeping that sequence number going continuously across the handover, PDCP prevents the packet loss and duplication that would totally confuse your apps and cause them to stall out or just disconnect completely.
Okay, so PDCP is the hero of our story, right? But what happens when the hero fails?
Well, the consequences are very, very real, and you've probably felt them.
Oh, you've definitely felt this before. That ciphering mismatch when the count value gets out of sync, that can cause a complete data blackout right after a handover. Or how about ROHC context loss? That's what gives you that awful, distorted robot voice on a call. And a reordering stall? Yep, that's the cause of that sudden, infuriating lag. All of these are failures at the PDCP level.
And for the engineers who have to build these networks, here's a little inside scoop. The toughest PDCP bugs are an absolute nightmare to track down. They often only show up for a split second, right in the middle of a handover, which makes them incredibly difficult to reproduce, diagnose, and ultimately fix.
So to sum it all up, PDCP really is the brain of the radio's second layer. It's this master juggler handling security, header compression, and mobility anchoring, all to achieve one single critical goal: to deliver a stable, predictable stream of internet data over a completely unstable and chaotic radio world.
You know, it mastered the insane challenges of 4G, it evolved for 5G. But as we start looking ahead to 6G, to a world with connected cars, drone networks, maybe even instant holographic communication, you just have to wonder, what new, even crazier forms of chaos will this unsung hero be asked to manage next?